Now let's talk about friction. Okay, we basically have two types of frictions. One is the friction between surfaces, okay, and the other is friction between fluids. Okay, the friction between surfaces is known as dry friction, okay, and the other friction is known as fluid friction. Okay, we are going to study dry friction. Okay, the fluid friction part is basically part of fluid mechanics, which we are not covering in this learning program. Okay, so we are basically interested in dry friction. Okay, to analyze dry friction, let us look at a block which is resting on a surface. Okay, let us suppose this is my block which is resting on this surface. We know that when the surface is frictionless, the reaction offered by the surface is normal to the surface. So this is the reaction. However, when the surface is rough, okay, when it is not frictionless, then we have a reaction at an unknown direction. Okay, we are going to try to understand what is this reaction and what is this unknown direction. Okay, I have a rough surface. Let us suppose I give a push of P newtons to this particular block. Obviously, if this push is small, this block is not going to move, right? So this block is not moving. Let me draw up FBD of this block when I have given it a small push and this block is not moving. So my FBD at this instant is going to be something like this. I'm going to have, this is my push, okay, this is my mg, where m is the mass of this block. Okay, now as the block is not moving, okay, it is in equilibrium. Okay, for this particular body to be in equilibrium, there must be a force acting in this direction equal to mg, and there must be a force acting in this direction equal to P. Okay, so these are the components of reaction offered by the surface. Okay, let us call this component as N, which is the normal component of the reaction, and let us call this component as F. Okay, where what is F and N? F and N are components of reaction, okay, due to the other surface, or due to the rough surface. Okay, N is my normal component, F is my horizontal component. Okay, now if I give it a bit more push, let us suppose I increase P from, let's say earlier I had given a push of 10 newtons, now I increase it to say 50 newtons, it is still going to be at rest. Okay, my F component is going to increase, however, because my F component is equal to the P component, which is equal to push. Okay, as I am increasing my push, the horizontal component of this reaction is also increasing. Okay, at a certain point, let us suppose at P is equal to 100 newtons, I reach a stage where this block is just about to move. Okay, so let us try to draw the FBD at that position. So this is my FBD when this block is just about to move. If I make this push just a bit larger, if I add say +1 Newton to this push, this block